The formation of fossils. A fossil forms when the hard parts of a deceased organism, such as bones, teeth, shells, or nails, are preserved under natural conditions over a long period. Though typically thought of as petrified remnants, fossils can also include perfectly preserved specimens, like mammoths frozen in ice or insects trapped in amber. Fossilization often requires rapid burial under sediment, which prevents decay of the softer tissues due to bacteria and environmental conditions. When an organism dies, its soft tissues decay quickly unless in very rare conditions, such as extreme cold or dry heat. The more durable parts, like bones and teeth, can last longer and undergo physical and chemical changes leading to fossilization. These changes generally affect vertebrates' bones and teeth, shells of brachiopods and mollusks, external skeletons of certain crustaceans and trilobites, coral and sponge outlines, and woody plant parts. The organism's environment greatly influences fossil formation, with underwater settings being more conducive than terrestrial ones. The most widespread fossilization process is permineralization or mineralization, where the organism is replaced by minerals from the soil. The stages of mineralization include rapid burial of the dead organism under soil, mud, or sand to shield it from air exposure. Subsequent sediment layers form a protective barrier against physical wear and external agents. Over centuries, the organism's hard parts undergo chemical breakdown, infiltrated by underground waters rich in minerals like calcite, pyrite, silica, and iron. These minerals gradually replace the original tissues, creating an exact stone copy of the organism over millions of years. Various fossilization scenarios include complete filling of the skeleton with mineral solution, followed by later breakdown, fossilizing the internal structure. Total replacement of the skeleton by a different mineral, producing a complete shell copy. Pressure-induced formation of an exact mold of the skeleton, preserving external surface details. In plants, carbonization often occurs, where bacteria replace oxygen and nitrogen with carbon and hydrogen. This process involves breaking down tissue molecules, leaving only carbon fibers. Such processes gave rise to coal beds formed from ancient swamps during the Carboniferous period, 354 to 290 million years ago. Organisms submerged in calcium-rich waters can become coated with minerals like travertine, preserving their shapes in the mineral bed. Complete fossilization of soft tissues is rare but has occurred, allowing for the preservation of internal structures from periods like the Cambrian, 543 to 490 million years ago. Fossils can vary significantly in size, from microorganisms to giant communal fossils. Notable examples include the sponge reef in Italy, composed of 145-million-year-old limestone sponges, and extensive fossil beds like Canada's Burgess Shale and China's Qingjiang, which contain thousands of Cambrian fossils. Other major fossil sources include amber beds in the Dominican Republic and Baltic Sea, the Green River and White River beds in the U.S., Eichstätt beds in Germany, and Hajula beds in Lebanon. By studying these fossils, scientists gain insights into the history of life on Earth, revealing that species appeared suddenly and fully formed, contradicting the theory of gradual evolution. Instead, fossils suggest that life was created in its complex forms, supporting the notion of creation.